scale up, scale out, and scale across. These aren't new terms, but for AI data centers, one of them has changed its meaning. If you want to find out more, stick around and we'll check it out. When we're talking about data centers, scaling isn't a new topic. But if we talk about AI data centers, we're not just talking about scaling the storage or the web traffic. Instead, we're talking about scaling hundreds and thousands of GPUs that need to work very tightly together, and a lot of times on a single task, like training a large language model. And what we need for that is high bandwidth links with very predictable low latency, as well as a very efficient collective communication between the different GPUs. And that's then where the how you scale becomes just as important as how fast your hardware is. So let's have a look at the first scaling possibility, and that is the so-called scale up. And what we do here is we take one system and we make it bigger or faster. How do we do that? We do that by adding more CPUs, GPUs, and memory into the one node or chassis. But as you can see, we very quickly reach the physical limitation of space or available slots. So the next scaling possibility is then the scale out. And instead of making just one system faster, we're adding more systems. So more servers, more racks, more nodes. And they're all interconnected and all in very close proximity to each other. And the result then a lot of times is a compute cluster. Now the scaling possibility after this is a so-called scale across. And this is where there's a difference between the traditional data centers and an AI data center. So if we have a look at the scale across of a traditional data center, what you see we're doing is we're actually connecting or interconnecting multiple compute clusters. So in other words, what we're trying to do is we're taking these scale out compute clusters and trying to make them appear as one bigger system. But the important part is they're all within the same data center or the data center campus. But this isn't possible for AI data centers because the modern AI clusters, they're actually running into the data center level limitation of available power and cooling capacity. So in other words, even if we have the space in the data center, we just can't continue to scale at some point because we don't have the power. And that's then why we have the AI scale across. And in this case, we are actually connecting two AI data centers that are literally at different physical locations. And we're not doing this for backup or load balancing. We're doing this so that they work together on a single training job. So in other words, this connection has now become, or this part of the network has become part of the compute fabric itself. So at this point, it is very important to note that the AI scale across scenario by no means is the default architecture for AI. On the contrary, pretty much all the AI training jobs still happen within data centers. And that's also the case for the hyperscalers. Why? Well, AI training jobs are extremely sensitive to latency and jitter and synchronization, which is why, technically speaking, this AI scale across scenario is extremely challenging. But in all fairness, there are deployments of AI scale across scenarios out there running. And also the technology is advancing extremely fast, and also that limitation, that power limitation of the data centers is also a real challenge. So it probably won't take very much longer for us to see more and more of the AI scale across scenarios being deployed. So I hope you enjoyed this video and that you learned something today. If so, please leave a comment. And of course, remember to follow our channel so you get your regular dose of brain snack. Until next time, bye-bye.